Last section in chapter 10 is dot product. Okay, so I think you guys will like this a little bit, but then we're going to make it a little bit harder. Okay, just going to be transparent with you with that one. Okay, so dot product is going to give you a number. Okay, so basically you're going to take the A values of your two vectors, multiply them, and then your B values, multiply them, and then add those two numbers together. Okay, so for part A, if I'm doing V dot W, okay, I get 2 times 5 plus negative 3 times 3. Okay, so 10 plus 9, negative 9 is 1. Okay, part B, W dot V, okay, so 5 times 2 plus 3 times negative 3, and you get 1. Okay, so this should tell you what is on actually the next slide, that dot product is commutative. Okay, so it is commutative. Okay. Letter C is V dot V. So 2 times 2 plus negative 3 times negative 3. So 4 plus 9 is 13. And then letter D is W dot W, which is 5 times 5 plus 3 times 3. So 25 plus 9 is 34. Okay, so far, so good. So far, so good. All right, letter E, magnitude of V. So that hasn't changed, guys. That's still the square root of A squared plus B squared. Okay, that's still the same. That didn't change. So for this one, I get square root of 2 squared plus negative 3 squared. So square root of 4 plus 9 is the square root of 13. And then F, magnitude of W, is square root of 5 squared plus 3 squared. So square root of 25 plus 9, which is the square root of 34. Okay, so. Okay, notice the two numbers under here are what the dot product are, because isn't that 5 squared plus 3 squared? Like, so kind of taking some things and putting them together here, guys. All right, so just some properties. We've actually already proven that one. Okay, so that one didn't change. Okay. V dot V is the magnitude of V squared, and anything times 0 is still 0, guys. That rule did not change from when you learned it a long time ago. Okay. All right, so the way that we can apply this is we can first find angle between vectors. Okay, so got two vectors. If we use this formula, we can find the angle between them. Okay. So I have to find my three pieces. So I need to find U dot V. So that's 4 times 2 plus negative 3 times 5, which is 8 plus negative 15, so negative 7. And then magnitude of U is square root of 4 squared plus negative 3 squared, which is 5. And then magnitude of V, which is the square root of 2 squared plus 5 squared, square root of 29. Okay, so then if I use my formula, I have cosine of theta equals negative 7 over 5 times the square root of 29. Okay, guys, you're going to plug this into your calculator. Okay, so the fact that there's a square root on the bottom does not matter. Okay, it is okay. Don't have to worry about that, because you guys know we're solving. Wow, I'm putting a bunch of letters together here. Okay, solving for an angle, have to use the inverse. So I'm going to do the cosine inverse of both sides. So I get theta is, and then I'm going to just type that into my calculator. So I'm going to do cosine inverse of negative 7 divided by. Now, please make sure you put 5 times the square root of 29 in parentheses. Otherwise, it's going to do negative 7 divided by 5 and then multiply that. Okay, so that's the one thing that I'm going to tell you have to make sure to do. Okay. So So you get 105.1 degrees. Okay, or 105, whichever one you want to put. Okay. All right. So taking and applying it a little bit. So a Boeing 737 aircraft maintains a constant airspeed of 500 miles per hour headed due south. Okay, jet stream is 80 miles per hour in the northeasterly direction. So it says express the velocity v sub a, so velocity of the aircraft, relative to the air, and then the velocity of w is the jet stream in terms of I and j. Okay, so guys, for just the airspeed, okay, we are going 500 miles due south. Okay, so that's basically straight down. Okay, so for v sub a, I'm going to get negative 500 because I'm going down, and then I'm going straight down, so that's my j factor. That's my vertical factor. So then v sub w is going to be 80 times, okay, now we're going northeast, right? Going specifically northeast. Okay, so halfway between 0 and 90 degrees is 45 degrees. So then I'm going to have cosine of 45i plus sine of 45j. So I get 80 times cosine of 45 is square root of 2 over 2. Sine of 45 is square root of 2 over 2. Okay. So then if I simplify it a little bit, basically those 2's both cancel, that becomes a 40. And I get something that looks like that. Okay. So then part B, so that's part A. So then the velocity of the 737 relative to the ground, so that's we're gonna call that v sub g, okay, is basically taking your airspeed plus your jet stream. So I get negative 500j plus 40 square roots of 2i plus 40 square roots of 2j. So just by distributing. So then if I rewrite this, I get 40 square roots of 2i plus 40 square roots of 2 minus 500 times j, just so I have it in ai plus bj form. So then part C says find the actual speed and direction of the 737 relative to the ground. Okay. So what that means is actual speed is going to be the magnitude of v sub g. So that's going to be the square root of 40 square roots of 2 squared plus 40 square roots of 2 minus 500 squared. So guys, I would just type that onto your calculator. Okay, and you get about 447 miles per hour. Okay, then you want to find the direction between the 737 and the ground. Okay, so basically what that means is you want to find the angle between v sub g and v sub a. So I'm going to use that last formula that we had. So I have v sub g, so I don't have to do anything with that, the magnitude. I do have to do the dot product. So I'm going to do v sub a dot v sub g, which will be 40 square roots of 2 minus 500 times negative 500, because there's no I term here, so it's just 0, over, and then magnitude was 447. Magnitude of v sub a, so basically if I do this, so it's going to be the square root of negative 500 squared, you get 500. So then I'm going to type all that into my calculator and get a number. So that tells me that cosine of theta has to be equal to 0.9920, and then find the inverse of that, which will give you about 7.3 degrees. That's probably the hardest problem that you're going to mess with story problems and taking our applications and applying them. All right. So, ways to determine if two vectors are parallel. So, if they're parallel, okay, your angle between your two vectors is either 0 or pi, or 180, because you might get 180 in your calculator, and that's the same thing. Okay. So again, I'm using this formula. So v dot w is 3 times 6 plus -1 times -2. So 18 plus 2 is 20. Magnitude of v is square root of 3 squared plus -1 squared, which is square root of 10. And then magnitude of w is the square root of 6 squared plus -2 squared, which is the square root of, so 36 plus 4 is 40. Okay, so then plugging it into this formula, so cosine of theta equals 20 divided by square root of 10 square root of 40. So type that into your calculator. You get this, so you get cosine of theta equals 1. And then cosine inverse of 1 is 0. Okay, so these two vectors are parallel because this angle that we got is 0. Okay, so usually when we talk about parallel, we also talk about perpendicular. Okay, so with vectors, we don't necessarily say that they're parallel. We say that they're actually orthogonal. Okay, because perpendicular and orthogonal, they technically mean the same thing, but orthogonal is used when we talk about vectors. Okay, so this one's the easier of the two, I think. So you want to find their dot product, and if their dot product is 0, then they're orthogonal. Okay, so we're going to find v dot w. So we get 2 times 3 plus -1 times 6, which is 0. So these are orthogonal. Okay. So usually if the question asks, determine if the vectors are orthogonal, parallel, or neither, I start with orthogonal first, then go to parallel, and if those don't work, then it's a neither. All right, so decomposing one vector into two orthogonal vectors. Okay, so basically, we're going to take v and w and break it down into v1 and v2. Okay, so we're going to follow this formula. So to find v1, okay, I need to find the dot product. So v dot w is 1 times 1 plus 3 times 1, which is 4. So you get 4 over magnitude of w squared. So square root of 1 plus 1, 1 squared plus 1 squared, and that whole quantity squared. So you get square root of 2 squared, which is 2. So you get 4 over 2 times your w vector, which is I plus j. Okay. So you get 2i plus 2j. So then to find v2, you take your original v vector, so I plus 3j, and you subtract the new vector that you just found. So I minus 2i is -i, 3j minus 2j is j. So these two vectors right here are orthogonal, and those are our two vectors that we decomposed from our original v. All right, so homework for this is 9, 14, 20, and 29. Okay, so this is the last learning for chapter 10. So we're going to be moving on to review and then test.